Hey, welcome back. SIVUS, Algebra 2, Trigonometry Unit, uh, Lesson 7-4, the seventh problem that I asked you to work on. So, taking a little sketch of a graph of 2 sine. It says, recall that the graph of f of negative x is a reflection of f of x across the y-axis. And so the way when I think about this one, I just think about the fact if I take all of my x's and I change them to the opposite, any x that was here is going to be over here, and any x that was here is going to end up over there. So that's just reflecting over the y-axis. So complete A through D below, 4 parts. All right, here we go. So 2 sine of x, remember sine on our unit circle was the y. So out here, sine starts at 0 because y is 0, 1, 0. It's a unit circle, positive rotation. And then we go up to our maximum here at pi over 2. Come back out here for sine to 0 at pi. And then when we get down here to 3 pi over 2, we're down at the negative lowest point y ever goes, -1. And then we finish up back at 2 pi with our full rotation. So there's your basic sine graph. We're talking about sine, but there's an amplitude of 2. So it goes up to 2 and down as low as -2. And it starts, this looks pretty good right here, doesn't it? Up to 2, down to -2, and ends right back there again. So I'm thinking, just take a quick look at the ones down below. Doesn't go here from 0 down to a minimum. That would be if it had been flipped, which this was just a plain 2x. Doesn't start at the low point, and then these two are for a couple of our reciprocal trig functions, and so we aren't talking about those. So let's go right back over here. Right here to see what we got. All right, nice work. Let's keep going to part 2. Clear off those drawings so I can see what we have here. What if it's a negative on the x? Okay, that's those directions at the top. Remember, a negative on the x flips it across the y-axis. So we were here, and a negative on the x is just saying, reminder, that's going to take all those, and they're going to go over here. So this point's going to be right here. This point's going to be up there. Going to finish this. So if we do that shape right there, still going up to 2 and down to -2, then that's the side of the graph. But is this graph? So that's kind of also like we're flipping it this way, because if you think about, normally it would have been there, it would have went down there. So this A looks pretty good. What's the difference between the A and the B? Well, we said we needed to go up, so that one's out. And these two being our reciprocal trigs, those aren't it. Again, we said from here we needed to go up. That one doesn't. Up. That one doesn't. So A is the 1. All right, put that in there. Find out that it says, hey, excellent job. Good. Let's move on. Clear all those off the screen there and keep moving on. By reflecting the graph, sketch the graph of the -2. So -2, remember we were started out with sine being like that. So the -2 is going to flip it over the x-axis. So now it's going to be going down, up, and it's going to go twice as high and low. So if this one was these blue ones that I had here originally, if these were the -1 and 1, and now if I switched them to have this 2 and flip it, so that's going to be this pink graph right here. So which one? This one doesn't go up from the origin. Reciprocal trigs. Oh, how about this F right here? That looks like it starts and goes up to 2. No, Nope. All right. I think F is the one. Uh-oh. So that was the one. Why did it say, was F not what a -2 sine? Let's go back here and talk again. So now it says, by reflecting the graph in part A, sketch the graph. Oh, let's see. What did I do wrong? Sine again. There's my sine graph. Finishes there at the 2 pi. And we want it to go twice as high and low, and instead of up, to go down. Oh, F doesn't go down. Where's the one that goes down from the, oh, here we go. Right over here. All right, look at that. I had the right drawing, but I picked the wrong answer. Let's get that D for the answer there, and we should be in good shape. All right, so sorry about that. I'll never mind showing you that sometimes I'll make a mistake too. Just keep after it, be determined, perseverance. And again, like I've said before, if you do need more, seek out more. So how do the graphs in parts B and C compare? So when we went to B and C here, again, on this one, we went down and then up and then down, and it was the amplitude of 2. So that was for C. So go up to B. What did B do? In B, we went down and then up and then down with the same thing. So really, they're the same. It's just the transformations were slight. The graphs are reflections of each other across the y-axis. I don't think so. Let's put this back over here again. Where's that one at? Right there. It lines up and does the exact same thing. So down, up, down with an amplitude of 2. Down, up, down, amplitude of 2. The graphs are the same. We've seen that before where you can do different transformations, whether it was a parabola, in a quadratic type of an equation, whatever it was, but looks like I've got a little spinning wheel going on here that's gonna, there we go, finally. All right, so there you have it. Transformations, sinusoidal, sine and cosine, reflections, amplitude. Those are the things involved in this problem. If I were needing a little more help, I would look at YouTube and I would go and type in those kinds of words. So hopefully that helps you. If you're having any trouble, look for more videos, bring me questions. We'll get it. Good luck, everybody.